Alright, hello guys. In this video, we're going to go over how to do first order linear differential equations. So these I would say are a step above separable differential equations, but really if we follow this process, you will be able to solve any first order linear differential equation. So the first thing I want y'all to notice is just recognize the form of whenever you see dy over dx plus some x and y term is equal to some x term, or the equation can be rearranged to look like that, then that would be considered a first order linear differential equation. As long as there's no y term on this q of x, which would be this one right here, then we can go ahead and apply it. So the first thing we're going to do is we're going to go ahead and identify p of x and q of x. So identify p of x and q of x. So what is our p of x? Our p of x will be strictly whatever is in front of our y term, the sign as well as the coefficient. So our p of x would be 3x squared, positive 3x squared, but not the y term. Note, this is not px of y, this is just p of x. And our q of x will be 6x squared. And we know this by just following the equation. So now the next step would be to identify the integrating factor. The integrating factor, which we will note as I of x, is a simple equation, which is just the exponential raised to p of x times d of x. And this is the most critical step, as a lot of people do go wrong on this. So one thing I would say is include the sign convention and the constant and the coefficient, because if you don't, you'll get different answers and your answer will not come out right. So knowing that our p of x is 3x squared, we will plug this inside the integral sign. And the next thing to do would simply just be to integrate what's inside the integral sign. So e raised to the 3x cubed over 3. And don't worry about adding the c constant. So all we simply do here is cancel the 3's out, and we're left with e raised to the x cubed. So now this is our integrating factor. Our I of x is equal to e raised to the x cubed. So now that we have our p of x, our q of x, and our I of x, we're going to go ahead and start to perform differential equations. So the next step would be to multiply both sides by the integrating factor. So our dy times dx plus our px of y, which was 3x squared y, we multiply it by our integrating factor, which was e raised to the x cubed, is equal to e raised to the x cubed times our q of x, and our q of x was 6x squared. So let's go ahead and distribute this out. So dy of divided by dx times the integrating factor e raised to the x cubed plus 3x squared y times e raised to the x cubed is equal to 6x squared times e raised to the x cubed. So now that we have it like this, now that we've multiplied both sides by the integrating factor, multiply both sides by the integrating factor I of x. The next step will be to take the integral of both sides. But here's the kicker though. The integral of I of x, to make this a lot simpler. The integral of I of x times dy over dx plus px of y is equal to simply I of x times y. So there's no need to perform all that arithmetic to integrate both of these terms when knowing that the integral of I of x times dy over dx plus px of y will simply just be the integrating factor times y. So there's actually no need to even distribute, but I did it just so you could see it. But just know that once you multiply both sides by I of x, integrating I of x times dy over dx plus px of y will give you just the integrating factor I of x times y. So knowing this, we're going to go ahead and take the integral of both sides. So our I of x would be x e raised to the x cubed times y is equal to, we pull the constant out of this right hand side over here. So we pull the 6 out and we integrate x squared times e raised to the x cubed times dx. And noticing that the difference of powers is 1, we can just simply apply u substitution to perform this integration. So our u will be x cubed. Our du will be 3x squared dx. And our d of x, solving for d of x, we get du divided by 3x squared. So now we go ahead and plug this back into the function. So our constant 6, x squared times e raised to the u times du divided by 3x squared. We cancel out our x squared. We notice that 6 and 3 can simplify to have a 2 constant on the outside. And that the integral of e raised to the u times du is simply just going to be e to the u plus c. So in doing this, our last step would be to just simply plug in the x terms back into u. So e raised to the x cubed times y is equal to 2 times e raised to the u. What's our u? Our u right here is x cubed plus c. And this is how you perform first order linear differential equations. So first step, identify p of x and q of x, including the constants and the negative or positive sign convention of p of x of y. Do not include y. The next step we did, identify I of x. I of x, use this formula. I of x is equal to e raised to the p of x times dx. And take the integral of p of x and then just use that as your exponent on Euler's number. After that, multiply both sides by I of x. Once you do that, integrate both sides. And knowing that this step right here, knowing that I of x times dy over dx plus px of y is equal to I of x times y will simplify a lot of your arithmetic. So don't perform the arithmetic, just know this. And then just integrate the right-hand side. And if you solve for y, go ahead, solve for y if you have to. If not, then that's how you do first order linear differential equations. Just follow the instructional, follow this video. Thank you. Hello guys, so in this example, we're going to do first order linear differential equation. But recognizing this is first order linear differential equation is not as obvious because notice how on the right hand side there is no x term. Right here it's just a 1. And notice how the dx of y is not isolated. So the first step we're going to do is we're going to go ahead and isolate dy of dx. So isolate, if you don't see dy of x isolated, go ahead and do that. Go ahead and isolate dy of dx. So in doing so, we're going to divide all terms by x squared. So x squared dy of dx plus x times y is equal to 1. Now we divide all terms by x squared, x squared, x squared, x squared. So the x squareds cancel out. So this is equal to dy of dx plus y over x is equal to 1 over x squared. So this is the function that we're going to be working with for this particular problem. And this problem has a form of first order linear differential equations. So we go ahead and apply all the steps as listed in the instructional to do this first order linear differential equations problem. So in order to do this, the first thing we do is we identify P of x and Q of x. So in doing so, in identifying P of x, make sure you include all the constants and all the positive or negative sign in front of the P of x. So in this case, and do not include the y. So in this case, our P of x would be 1 over x. And our Q of x would just be 1 over x squared. And do not include y for P of x, just include the x term. Our next step would be to identify the integrating factor, which will be noted as I of x. Identify the integrating factor I of x. So I of x is equal to the exponential raised to the integral of P of x d of x. And this is where a lot of people do mess up, so that's why it's absolutely critical that you identify your P of x properly, because sign convention, constants, coefficients in front of the x do play a role in what your integrating factor turns out to be. So this integrating factor in this case will be e of x raised to the integral of 1 of x times dx. So we integrate this, we get e is equal to the natural log of x. And knowing that the exponential raised to the natural log will cancel each other out due to the natural log and exponential properties. So our integrating factor would essentially just be I of x is equal to just x. So our P of x is 1 over x, Q of x is 1 over x squared, and I of x is equal to x. So now we're going to go ahead and apply the problem solving steps. So our next step would be to multiply both sides by the integrating factor. So multiply both sides by the integrating factor. So our integrating factor was x. So we multiply x times dy over dx plus y over x is equal to our q of x. And our q of x was simply just 1 over x squared times our integrating factor of x. So we apply algebra, take this a step further to just simplify all the terms. X times dy over dx plus y, because these two x's will cancel each other out, is equal to 1 over x. And now doing this, the next step would be to integrate both sides. And this is another key step. Whenever you take the integral of I of x times px of y plus dy over dx, that integral will always be equal to the integrating factor times y. So don't worry about going through all the arithmetic of integrating. Just know that that integral of the integrating factor times your y prime, your dy over dx plus px of y will always be equal to the integrating factor times y. So on your left-hand side, our integrating factor was x. So x times y is equal to the integral of 1 over x times d of x. And that integral would be equal to the natural log of x plus c. And if you need to take it a step further, you just, to solve for y, just divide both sides by x. But otherwise, this is how you perform first order linear differential equations. So if your form of your equation, as in this problem, did not have dy over dx isolated, go ahead and isolate that. If not, once it is isolated, divide both sides, or identify your p of x and your q of x. Then afterwards, using this formula, identify your integrating factor, which is a key step as well to getting this problem right or wrong. Then you multiply both sides by I of x. Then you integrate both sides. And in doing so, you will be able to perform any first order linear differential equation. Hope that was helpful. Thank you.